Very good. Let me begin by reviewing and recalling our discussion last time. So last time, we discussed the chain rule. This chain rule says that the derivative of f of g of x, the derivative of f of g of x is equal to f prime of g of x times g prime of x. In other words, we can also write it like this. We can also say that the derivative of f of u is f prime of u times u prime. So for example, so imagine you have h of x equal to square root of x cubed plus sine x. Okay? So here you can say that, for example, you can let u be x cubed plus sine x, then u prime is just 3x squared plus cos x and you can say that f of x, suppose that f of x is root x, then h, the function h, is just equal to f of u, right? H is f of u. So that means h prime is equal to f prime of u times u prime. Oh, by the way, if f of x is equal to root x, then it follows from here that f prime of x is 1 over 2 times root x. Okay, so h prime is f prime of u times u prime. So that is equal to f prime of u is 1 over 2 times root u, so root of x cubed plus sine x. And u prime is just 3x squared plus cos x. So let me just write it on the top. So u prime is 3x squared plus cos x. Is that clear?
Yeah, that's clear.
Okay. Okay, so that was the chain rule. Today I'm going to discuss the derivative of exponential and higher order derivatives. So first, look at the derivative of exponential functions and logarithm. So the derivative of exponential. So let me just say, instead of an exponential, I just write derivative of e to the power x and log x. So exponential and logarithm. First of all, recall that we have this number e, e to the power x. E is an irrational number. Recall that. E is an irrational number which is about 2.7. And you have the function f of x equal to e to the power x. This is the exponential function. Its inverse is called natural logarithm. So f inverse of x equal to, so the natural logarithm is basically, we write it by ln. So the symbol for natural logarithm is usually ln. So we just write ln of x. And keep that in mind that ln of x means logarithm with base e. So the natural logarithm is the logarithm whose base is e. So that means when I say they are inverse of each other, e to the power x and ln of x are inverse of each other, it means that, let me write it here. So when I say, for example, that log or ln of a is equal to b, that means, so this is if and only if a is equal to e to the power b. So ln of a is equal to b is equivalent to saying that a is e to the power b. And today we are going to learn that. So this is a theorem, important theorem. The theorem is that the derivative, if f of x is e to the power x, then the derivative of e to the power x is just e to the power x. This is an amazing property of exponential. That is, the derivative of exponential function is itself. So the derivative of e to the power x is just e to the power x. And if, what about the derivative of ln? If f of x equal to ln of x, then f prime of x is 1 over x. So the derivative of e to the power x is e to the power x, and the derivative of ln of x is 1 over x. So keep these two formulas, these two equations. You can add these two into our list of the derivatives. So far we have learned the derivatives of x to the power n, any power of x, like x squared, x cubed, square root x. Then we learned the derivative of the sine, cosine, tangent, cotangent, secant, cosecant. And now we learn the derivative of e to the power x and ln of x. Any question so far?
No, everything's fine.
So far, so good?
Yeah, so far so good.
Okay, very good. So let us do some examples. So for example, let's look at these functions. F of x is equal to e to the power x squared. So how to compute now the derivative of this guy? Here we can use the chain rule, right? So we can say that let, for example, let x squared be equal to u, then u prime is just 2x, right? And let me write, like, for example, g of x equal to e to the power x, then g prime of x is again e to the power x. What we know here is that we know that f of x is equal to g of u, right? Is that correct? F of x is g of u, because g of x is e to the power x and u is x squared. So g of u is just e to the power x squared. So f of x is g of u. So f prime is equal to u prime by the chain rule times g prime of u. So f prime is equal to, what is u prime? U prime is 2x. What is g prime? G prime is e to the power x. So g prime of u is just e to the power x squared. Okay? So the derivative of e to the power x squared is just 2x e to the power x squared. And here is an important lesson, actually. A lesson is that, so in general, the derivative of e to the power u for any u. So here u is x squared, but it could be a square root of x, or it could be x cubed. It could be cosine x. So for any function u, the derivative of e to the power u is just u prime times e to the power. So the derivative of e to the power u is u prime e to the power. Another example, so example 2. So for example, f of x is equal to ln of square root x. So here we can just say that, we can say let square root x be u, then u prime is 1 over 2 times the square root x. And we can let g of x be ln of x, then g prime of x is 1 over x. But here what we know is that f is just g of u. So f prime is equal to u prime times g prime of u. So f prime is equal to u prime 1 over 2 times root x times g prime of u. G prime of x is 1 over x. So g prime of u is 1 over u times 1 over u, which is root x, which is equal to, if you multiply these two, you get 1 over 2x. So again, another lesson is that the derivative of ln of u for any function u. Here u is root x, but it could be cos x, x cubed, whatever. So ln of u prime is just equal to u prime over u. Any question? Okay. Let's go to another example. This is example 3. So example 3, now look at this function. F of x equal to x e to the power x squared. So what is f prime? So f prime of x is, now here we have product, x times e to the power x squared. We have to use the product rule. The product rule says that the derivative of like two functions is the derivative of the first one times the second one plus first one times the derivative of the second one. Remember, and just recall that I just told you that the derivative of e to the power u, so e to the power u derivative is u prime e to the power u. This was a lesson we just learned. Derivative of e to the power u is u prime times e to the power u. Okay, now let's look at this formula. Go back. So f prime here is x prime. The derivative of x is 1. So it's just e to the x squared plus x times the derivative of e to the x squared. Here I have to use this formula. The derivative of e to the power u is u prime e to the power u. So u here is x squared. So what is the derivative of x squared? So 2x. 2x times e to the power u, e to the power x squared. So f prime of x is e to the power x squared plus 2x squared e to the power x squared. You can even simplify and rearrange these terms. If you factor out e to the x squared, you get 1 plus 2x squared. Now, in many applications, a critical question is at what point or at what points the derivative becomes zero. Now, if they ask you such question for this function, what would be the answer? At what point the derivative is zero? So this is just another question. But this you see it in many applications. So at what point f prime, so that's the question. Question is for what x, f prime of x equal to 0. So that is e to the x squared times 1 plus 2x squared is 0. So that means because e to the power anything exponential is always positive. So this guy is always positive. It cannot be 0. So that means, so this implies that 1 plus 2x squared must be 0. Is that possible? No. Because 1 plus 2x squared is always greater than or equal to 1. So this is impossible. Because this guy is also always positive. So there is no x for which f prime is 0. No solutions. Okay. So far, so good. Any question? Okay. Let's move on. Now I want to tell you about higher order derivatives. So higher So we have second derivative, third derivative, fourth derivative. It is just repeating the derivative. So if you have a function like f, if you take the derivative once for the first time, you get f prime. If you do it again, so f double prime is by definition just f prime prime. It is the derivative of the derivative. And you go on, like third derivative. And fourth derivative. But for derivatives of order 4, 5, we don't use the prime sign. We usually use the number in a bracket. For example, 4, we put 4 in a bracket like this. That means the fourth derivative. Fifth derivative. And so on. Okay. So for example, if f of x is x cubed, then what is f prime? Is 3x squared. What is f double prime? So f double prime, you just take the derivative again. So what is the derivative of x squared? 2x, right? So the f double prime is 2 times 3 times x. So it is 6x. What is the, this is the second derivative. What is the third derivative? F triple prime. Is just 6 because the derivative of x is 1. What is the fourth derivative? What is the fourth derivative? Betty.
0.
0. Exactly. So that's it. I mean, this is not a new concept. It's just doing derivative over and over. Another example. So f of x is, imagine that it's ln of x. Then f prime of x, as we just discussed today, is 1 over x. So the derivative of natural logarithm is 1 over x. So which is, you can write it as x to the power minus 1. So the second derivative is the derivative of x to the power minus 1. Right? Now, what is the derivative of x to the power minus 1 or 1 over x? Minus x to the power minus 2, which is the same thing as minus 1 over x squared. And you can continue this process. Right? You can say that the third derivative is just 2, because minus 2 times minus 1 is just 2. 2 times x to the power minus 3, which is 2 over x cubed. Now a good example, which is very nice. Look at e to the power x. So what is f prime? E to the power x. F double prime, e to the power x. F third derivative, e to the power x. So this is very easy. So before going back to this question, I just wanted to tell you something. For Monday, if you go look at the website, let me share my screen with you. Do you see my screen here? Do you see my screen?
Yes.
Okay, for Monday, please look at the unit derivatives. Please do assignment 2 and 3. This is assignment 2 and assignment 3. So write your answers on paper and hand in your assignment in person on Monday. Okay? So this weekend you have to work hard. I'm sorry. Okay? So do assignment 2 and 3 on paper and hand in your assignment in person on Monday. Okay? Okay. Okay, now let's go back to the exercise that I gave you. So Kenny, tell me please, what you get for part A? What is F prime?
I'm still working on it.
Even for F prime?
F prime?
Okay. How about you, Sherny?
For A,
A. Yeah. We discussed something very similar here. I mean, this one, not this one. Where was it? Here. Do you remember? So f prime is what?
is it 1 minus 2x squared over e, was it exponent? Yeah, over e x squared.
It's like this, right? So e to the power minus x squared is the same thing as 1 over e to the power x squared. Because you have a negative power. So now what is the second derivative, Cynthia? F double prime.
I didn't do the second derivative yet.
So do it and tell me.
For A, I have to leave my answer like how you did it, right? I can't do it over like ex squared.
I mean, sorry, what is the problem?
Do you want me to leave the answer how you did it, or
Yeah,
is it
I mean, it's easier. You don't need to put it in a denominator.
okay?
I mean, so this is, let me tell you. So it's more common to write e to the minus x, for example, instead of, these are equal. We know that these two are equal, 1 over e to the power x, right? 1 over e to the power x is the same as e to the power minus x. Negative power, right? Does it make
Yeah.
sense? But we usually write e to the power minus x. That's something more common. But both of these expression, they're accurate. So you can use either.
For the second derivative, would it be negative 4x and then ex to the power of negative x squared?
Okay, so the second derivative, let's see. Here again, we have to use the product rule, right? Because you have the product of two functions. So the derivative is the derivative of the first times the second minus the derivative of the second times the first.
Shouldn't be plus instead of minus.
Oh, sorry, plus. Why I said minus? Thank you. It's plus, yes. Okay, so now let's do it. What is the derivative of 1 minus 2x squared? Hmm? Negative 4x. And then you just multiply it by e to the minus x squared. Now, what is the derivative of e to the minus x squared? Times. So the derivative of e to the power u is u prime times e to the power u. So here you have to compute the derivative of minus x squared. The derivative of minus x squared is minus 2x. So let me write it here. This is very important. Please listen. The derivative of e to the power minus x squared is the derivative of minus x squared times e to the power minus x squared. Because, as I said a few times, the derivative of e to the power u prime is u prime e to the power u. I mean, is this clear? Because this is extremely important. Is it clear for you? This rule. The derivative of e to the u is u prime times e to the u. Like the derivative of e to the minus x squared is minus x squared prime times e to the power minus x squared. But the derivative of minus x squared is just minus 2x. So it's minus 2x times e to the power minus x. Okay. So that is f double prime. If you simplify, so f double prime is equal to one minus 2x squared, or you can let's do like this way. If you want to simplify this, so it's e to the power minus x squared times 2x. I factor this times 2x times, or let's say times minus 2x times. So the first one, you get minus 4x. So it is 2. The second one, you have 1 minus 2x squared times minus 2x times e to the power minus x squared. So it is like 1 minus 2x. So finally, let me just copy this. This is just some algebraic manipulations. At times, I mean, later you will see why these things can be crucial sometimes. Anyway, so f double prime is e to the minus x squared times minus 2x times 3 minus 2x squared. Okay, how about B? Betty, have you done part B? So for part B, there is no chain rule. It is just the quotient. This is just quotient.
Is it 1 over x squared? I mean, 1 minus x squared over 1 plus x squared squared?
You mean f prime? You're talking about f prime, right? F of x is x over 1 plus x squared. So f prime, so the quotient rule says that the derivative of, like a quotient is the derivative of the numerator, like x prime, times the denominator, minus the derivative of the denominator times the numerator over 1 plus x squared over the denominator square. Now the derivative of x prime, I mean the derivative of x is just 1, so you get 1 plus x squared minus the derivative of x squared is 2x. So it's 2x times x, so it's minus 2x squared. So you get f prime is, it's 1 minus and divided by 1 plus x squared. 1 minus x squared over 1 plus x squared squared. Now I can ask you this question. At what point the first derivative is 0? I mean, at what point the f prime is 0? For what values of x, f prime is 0?
1,
And
0,
no. -1. Because look, f prime 0 means 1 minus x squared equal to 0. It means x squared equal to 1. It means x is plus minus 1. So that was something aside. I just wanted to ask you this question. But what is f double prime anyway? Who computed the f double prime? Again, you have to use chain rule. I mean, not chain rule, sorry. We did lots of chain rule today. Quotient rule. You have to apply the quotient rule. So this is f prime. So f double prime would be the derivative of the top times the denominator minus the derivative of the denominator, 1 plus x squared prime times the top, 1 minus x squared, over 1 plus x squared to the power 4, right? Now the main question is what is the derivative of 1 plus x squared squared? So what is the derivative of this guy? Here, what you can do that helps you is to say, okay, let u be equal to 1 plus x squared. Then you have like u squared, right? So the derivative of u squared is 2 times u prime. This is the chain rule. The derivative of u squared is 2 times u prime. So if u is 1 plus x squared, then u prime is 2x, right? So u squared prime is 2 times u, which is 2 times 1 plus x squared, times u prime, times 2x. So, which is equal to 4x times 1 plus x squared. So that means the derivative of 1 plus x squared squared is exactly equal to 4x Now just plug in this to your equation. And by the way, here you have the derivative of 1 minus x. I dropped it. So here is 1 minus x squared prime. Because by the quotient rule, the derivative of the quotient is the derivative of the numerator, which is 1 minus x squared, times the denominator minus the derivative of the denominator times the numerator over denominator square. Right? Now let's plug in. These are some side computations. We can raise this part. I just keep the result, which is the derivative of 1 plus x squared squared. And I plug all the data here. So f double prime is, what is the derivative of 1 minus x squared?
Negative 2x.
Negative 2x. So it's negative 2x times 1 plus x squared minus the derivative of 1 plus x squared, we have it here, is 4x times 1 plus x squared. Times 1 minus x squared. Over 1 plus x squared to the power 4. Now on the top, you can factor out minus 2x times 1 plus x squared. If you factor out this, so you get, so here you have minus 2x times 1 plus x squared squared. So you have 1 plus x squared from the first term. And from the second, you have minus 4x times 1 minus x squared. So it's plus 2 times 1 minus x squared. Divided by 1 plus x squared to the power 4. Then you can simplify, because on the top you have 1 plus x squared. At the bottom, you have 1 plus x squared to the power 4. So they cancel out each other. So on the top, so 1 plus x squared is gone. Here the power would be cubed. And you get so f prime is equal to, on the top you have minus 2x times, here you have 1 plus x squared plus 2 minus 2x squared. So 1 plus 2 is 3. X squared minus 2x squared is minus x squared. And then divided by 1 plus x squared cube. Right? Maybe I can just erase this and write it. So over good. Which face is your face? You have to choose.
Crying.
Okay, so you can start working on your assignments. I mean, you started working on last session, but you can continue. And if you have any questions, I'm here. So let me, for instance, let 1 or 2 of the questions for you. This is just for help.
Well, I do have a question on the assignment that I need help with.
Okay, what is your question?
Give me a second.